Hello everyone! In our previous video, we explored how text classification problem can be solved using different type of models like encoder only and generative models. Our today's goal is to classify movie reviews into positive or negative categories. For this, we will be using a dataset called as Rotten Tomatoes. It's a dataset full of reviews labeled as either positive or negative. Sounds simple, right? You can imagine it as teaching a model to read a review and decide if a person loved or hated the movie. Without wasting any time, let's actually implement this project. So, we will be doing text classification using task-specific encoder-only model. So, we will be using Google Colab for this particular project, and we will change the runtime and set it as GPU, whichever GPU is available, and let's connect it. The first step is installing libraries. So we will require libraries like datasets and transformers. Let's run this. Now that library installation is done, let's go to next step, that is loading the data, loading the dataset. Let's load the data. So we will be using datasets library load dataset function. We will store the entire data in this data variable and use load dataset function, and we will just provide the name, that is Rotten Tomatoes. That's it. Let's print this data. For the first time you run this block of code, it will download the data. So this is the output after printing the data. We can see that it consists of three parts: the train part, validation and test split, or three splits we can say. This train split contains features like text and label, and total data points it has is 8530, similar with validation and test. Now let's explore the data. Let's print the first data point. So print data of train of 0. So it will print the first data point which is present in the train split. So here we can see that it has text something and finally the label associated with this particular text. Here label 1 means positive sentiment or positive review, and label 0 means negative review of that particular movie. Let's print 6000. Like this you can play with this data and explore this data. So here the text in the script isn't very good and this is like a negative review. Let's see its label is 0. So in this way the data is structured. Now let's directly jump to the portion of text classification with representation model, that is task specific. So let's first load the model and the tokenizer part of the model. And if you are not aware what is tokenization and want to learn more about tokenization, I have made this dedicated video specially on tokenization. So please watch that video. Let's import the model. Before that, we need to import the transformers library. From transformers import pipeline. So we will be using this model from Hugging Face Hub, Cardiff NLP / Twitter Roberta base sentiment latest. This particular model is a fine-tuned Roberta model from Hugging Face Hub. It's actually trained on tweets for sentiment analysis and it is not trained on movie reviews specifically. But hey guys, we are about to test how it works with movie reviews. That's what makes this particular project exciting. Even though it is not trained on movie reviews, it's really cool to see how well a model trained on something else can generalize to completely different dataset. So let's load the model along with the tokenization using pipeline functionality. So here the first argument is model ID. Then we give tokenizer. Tokenizer we will use the same model ID. Then we need all the scores. So return all scores. The importance of it you will get to know. And then finally the device in which we want to load this model, CUDA 0. Let's run this block of code. If you are running this for the first time, it will download the model and load the tokenizer part as well as the model part. Now that we have successfully loaded the model as well as the tokenizer, let's perform predictions. Before that, just wait a minute. What we will do is, let's say we get this variable like test data, and we store the entire test set in this test data variable. Okay. Now let's take a sample data point from test data, sample test data point, and let's store this here like test data of 0, and we want to infer on text, right? So that's it, text. Now what we will do is, we will have something called as inference, or let's suppose my prediction. So prediction will be equal to, we will call this pipe functionality, and we will just give this input and of 0 and print this prediction. This is just to check how model is behaving before we actually do the entire inference on entire test data. So this is the output of the model, that is prediction. Let's print what's there in test data of 0 of text. So this text is this one, and if you read this particular text, you can directly say that this movie review is positive review, and till now the model is performing decent or good. Now let's actually do the prediction on entire dataset. But wait a minute. What we saw was, this particular data has only two labels, that is 1 and 0, right? Positive and negative. But our model is giving neutral as well. Now what to do with this neutral? We cannot give neutral, right? We can only have negative and positive. So what we can do is, let's suppose what we will do is, we will take negative score and positive score, and we will take maximum of these two and then classify the data point as positive or negative. Okay, so we will take negative score and we will have something called as positive score. In this negative score, in prediction, so always in prediction the first element is negative score, right? So prediction of 0 dot get score. So this is our negative score, and positive score. Positive score is like in the last element. So prediction of 2 dot get score, or here we can also write -1 or 2, whichever prefers. Now what we will do is, we will be having final prediction. Final prediction will be equal to np.argmax. Now what we will do is, it will select the maximum of negative and positive score. So let's input negative score and let's also input positive score, and let's print final prediction. There is some typo error. Let's just copy paste and rerun it. Now we can see that the final prediction is 1. Now let's do the evaluation on entire test set. So we will have predictions list for test data point in the entire test data. Now this test data is this one, or here we can also write data of test, whichever you prefer. So test data. Okay, so here we will have prediction, which will be equal to pipe, the similar thing like a test data point of text of 0. Then we will have negative score, which will be prediction of 0 dot get score, or dot get and score, and similar for positive score. But here we will write 2 or -1, whichever you prefer. Then we will have final prediction. Final prediction will be equal to np.argmax. Here we will give negative score and positive score. Then we will append this prediction, like, okay, that's it guys. Now finally, just to make it more beautiful, what we can do is we will just print progress bar. We will have a progress bar. So from TQDM, import TQDM, and we will write TQDM here, and simply we'll write the description as predicting. Let's run this block of code. So now here we can see the speed at which the predictions are going on. So total there are 1066 data points in test data split, as we saw here. Here 1066 data points in test. The inferencing part is complete in 18 seconds. Now, how do we evaluate this particular model? In order to evaluate this particular model in terms of, let's suppose, accuracy, F1 score, precision, recall, we need to compute something called as confusion report, confusion matrix or confusion reports. In order to do this, we need few functions from sklearn. So from sklearn.matrix import classification report. Okay, my bad, this is not confusion report, this is classification report or confusion matrix. Sorry for this. Now we have the true labels in the test data which we already downloaded, right? Then we will have classification report, which will be equal to, we will call this function, this will be classification underscore report. So here let's report classification report, then y true, then we will have predictions, which is the list which we already computed. Then we will have target names. We will just give target names as negative movie review and positive movie review, and we will simply print this report. Hooray! We have solved the classification problem here. So now if you want to analyze this, you can directly see the accuracy part, that is 80%. So here we can see that even if we are using the model which is not trained on movie reviews but it is trained on Twitter sentiment analysis, we are getting a classification accuracy as 80%. Now here you can also view class wise precision, recall and F1 score. So that's it for this video guys. If you have any doubts or questions in your mind, do ask me in the comment section. I will make sure to solve all your doubts, and also like this video and share it with all your data enthusiast friends. Thank you.